Okay guys, we are going to cover chapter 4.2 today, and this is simplifying algebraic expressions. So I've talked a lot about the word simplify, and we're going to learn a lot more about what simplifying really means, and we're going to do that with algebraic expressions. So here's all your key concepts for the day. Yes, you do need to copy everything, and yes, you do need to copy in this chart down here. And then when you've got it all copied, go ahead and replay me and I'll explain them all. Okay, so the first one we've got up here is a term. And a term is addition and subtraction signs separate an algebraic expression into parts. And each part is a term. So like down here, we have, this expression has 4 terms. So here's a term here, here's a term, here's a term, here's a term. As you can see, all of these are being split up by a addition or subtraction sign. Let's do yellow, right? So here's an addition, here's an addition, here's an addition, right? So it's being split by addition or subtraction. Subtraction could be in there too. And then we've got coefficient, and this is the number part of the term that contains a variable, or you can think of it as the number in front of the variable. So, like down here in this example, we have 3x. 3x, the coefficient in this case is 3. So it's the number in front of the variable. Then we go on to like terms, and I've used that a lot in class lately. Like terms means it contains the same variables in the same powers. And we're not really going to deal so much with powers right now, but just know that that's also true. So like terms over here in our little example, like terms, we have 5y and 2y. And what makes them like? Well, what makes them like is that they both have y's on the end. Similarly, if I had, let's see, 3x plus 4x. Okay, both of these have the same variable attached to them, so that makes them like terms. And then we have constant is a term without a variable. So a constant is really just a number, and a number by itself. So in this case down here, what's the constant? 2, 7, 3. Those are all constants. And then we've got simplest form. And if it has no likes, no like terms and no parentheses, so if we can get it all the way down, it is in simplest form. And then simplifying the expression is what we're going to do today, is combine all like terms and perform all possible operations, including the distributive property. Okay, so that's quite a bit of key concepts, but we're going to be using all of those today. Down here, the coefficient of x is 3. We talked about that. The coefficient of x is 1 because x equals 1x. Now that's kind of a big thing that came up on our last test. Remember, anytime that the variable is by itself, whether it be x or y or, you know, what have you, z, element of p, if they're all by itself, then the number that's going to be in front of it, the coefficient that's going to be in front of it, is always going to be 1. It's kind of an understood. Okay, so here's our first example. Identify the like terms in the following expressions. So first of all, we're just going to talk about the like terms. Now, our like terms, remember, let's go back here, it contains the same variable. Okay, so out of here, which ones contain the same variable? Well, I see a 3x here and a 4x here. So my like terms, 3x and 4x, and that's it. I can't do anything with this y here, because this 4y, because there's no other y to go with it. You try this one. Pause me and replay me when you're ready for the answer. Okay, so in this case, we have a couple of like terms. We had 5x and 7x. That's one like term. Now we also have another like term of this positive 3 and this positive 4. So I have 3 and 4. So I can have two sets of like terms. That's okay. Okay. Now I have an I do. So we'll be asking for the terms, the like terms, the coefficients, and the constants in the following expression. Now, if you need to go back and check on our key concepts to figure out what those words mean, that's fine. But by the end of our practice, hopefully, we know what those words mean. Okay. So our terms. Remember what a term is that it's anything being split between addition and subtraction. So we're just going to list off our terms. 6x, comma, negative 2y, comma, x, comma, negative 5. Notice I'm not putting in the addition or subtraction marks between them, but a comma to separate them. And then we've got our like terms, so we want to put our variables together that are alike. So we have 6x and x are one like term, and that's the only like term we have in here. Our coefficient, remember, is the number that's in front of the variable or attached to the variable. And here we have 6, negative 2. And then what happens in front of this x? Remember that little sneaky 1? And we're not going to put a negative 5 because there's no variable, so that's not necessarily a coefficient. But it is a constant, so we're going to put in negative 5 down here. Now, sometimes you might not fill in every single category, and that's okay. Okay, so sometimes I might not have a constant, there may not be any like terms, so you'll just leave that portion blank. You try. And replay me when you're ready for the answer. Okay, so our terms were 3n, 5m, negative 6m, 2. Like terms, 5m and negative 6m. Coefficient, 3, 5, negative 6, constant, 2. Okay, so now we're going into simplifying the expression. Okay, so when we're simplifying the expression, remember we've got to get all of our like terms combined, no parentheses, no nothing like that. So what I like you to do is I like to rewrite the problem so that my like terms are near each other. And in this case, I have a like term of 4x and 2x. So I'm going to write those like terms next to each other and add 6 at the end. So then I can combine 4x plus 2x, and when I do that, I just add the coefficients and I get 6x plus 6. And that's it. Okay? Again, we're going to rewrite 5n minus n plus 2 minus 6. And I can do this because of what property? Well, commutative property, remember, tells me I can move things around. It still is the same. So all I'm going to do is I'm going to move my key or like terms, right, together. And then I've got a plus 2 and a minus 6. That's where I get that. So I get a 4n minus 4. All right, and one more for me. This one has a parenthesis in it. So we want to make sure we eliminate that parentheses first. So I'm going to distribute that negative 3. And I get 6y minus 3x and plus 6y. And remember, distributive property, we have negative 3x minus 2y. When I do this, I get negative 3x minus a negative 6y, which is negative 3x plus 6y. Okay, so that's how I got that right there. All right, and then combining, I get 6y plus 6y minus 3x, 12y minus 3x. And yes, I would like you to go ahead and take this step to rewrite so your like terms are next to each other. It makes it easier when your problems get bigger. Okay, you do. All right, and we should have put 4x plus, minus, oopsies, 4x minus 3x plus 6. 4x minus 3x is x plus 6. And I don't need to write that 1 because it's an understood 1 in front of it. Okay, you do this one as well and replay me when you're ready for the answer. So we should move our 2m minus 7m together and our 3 minus 4 together. And we have a 2m minus 7m, which is a negative 5m. And a positive 3 and a negative 4 is a negative 1. So we have a negative 5m minus 1. Okay, and another you do. Try this one as best you can. This one has parentheses in it, so I have to do distributive property. And then replay me when you're ready for the answer. 4q plus 32p plus p. Notice I did not distribute to this p over here because I'm only doing what's inside the parentheses. So then my like terms are already next to each other, so I'm just going to go ahead and add 33p. Okay, guys, that's all we have for today. So please get these practices 1, 2, and 3 go along with these instructions. 4, 5, and 6 go along with simplifying the expression. Good luck.